All right. Similarly, if you use the same definition for this one, let's say U H U H W, you get what? 6 terms here, 6 terms here. You will have 36 terms, but then you can group them like this, and there will be only 6 many terms. So this will be just 6 times. So you will feed this guy into this one. W, and then the other 6 gadgets. So what is that? Instead of U, you will keep this one E, and then this guy U, this guy W, and so on. So we have 6 many terms. But again, you have here 6 factorial. Okay, so to avoid such things, we make the following definition. We don't use the definition given by tensors, but instead we make following convention, which will make life easier. Okay. So to avoid these coefficients, so here, of course, this 6 is just 3 factorials, and here this 2 is just 2 factorials. Okay, so here we have 2 factorials of this gadget, and here we have 3 factorials of them. And you see, if you have n terms, then you will have n factorial. So to avoid these coefficients, we make the following definition. If W is, let's say, this guy, Q1, with n many terms, in graph, and wedge product of B, then we define its dual is defined as şöyle tarif edilecek. Bunların duallerini alacağız. Ama önüne 1 bölü n faktörünü ekleyeceğiz. Okay? So the dual of this object, we would expect this gadget, but we will be a little bit, we will use a little bit different object. We will divide it by n factorial. This way, we get 1. So if you have this gadget evaluated on this, which is just so E, okay, 1 over n factorial, E1 wedge, and wedge evaluated on E1 wedge En will be what? Şimdi nasıl yapacağım? Her birini yiyecek değil mi? But as this guys eats this guys, since they are dual elements, here I take this thing as a basis and this thing as a basis. They are dual elements. So if EI star will eat EJ and it will be equal to delta IJ. Therefore, as long as, so here there will be n factorial terms, no, n factorial times n factorial terms, right? This has already n factorial terms, and this has already n factorial terms. So in total, you will have n factorial times n factorial terms. But most of them will be zero because if if the ith term here it's j term, and if I and j are different, then you will get zero. So only if this indices match, you get 1. Yani mesela şöyle, burada E1, E3, E2 star varsa, pardon. Yani şöyle, bunların hepsi star tabii. Yok, şunu şöyle yapacağım. Bunun içinde mesela şu terim var gibi. Suppose this is inside this one, right? This here, I take n equals 2, let's say. I have this, and then it will eat this one, E1, cancel E3, E2. If you get this, you will get 1 because it matches. But if you have this term here, it will give me 0. So only those with matching indices will give you 1. And how many of them do we have? N factorial, right? I have n factorial terms here. For each fixed permutation, the corresponding permutation here will give me 1. All others will give me 0. So I will have n factorial many ones. Therefore, the result will be just n factorial. But you have already n factorial here, so the result is just 1. Okay? So here, if you don't put this term here, then the result of this will not be 1 but n factorial, and that's not something you want to, hear. Anlaşıldı mı? Yani şu bir çıksın diye, çünkü yani so if my vector space has a basis, let's say so B has a basis delta and let's say E1 up to the ends and dimensional. These are my basis elements. They will be my basic elements. Onu da ispat etmedik, tamam. And you want this thing to be, 1, but then you have to make this conversion. Evet.
Hocam şimdi W'nun 50 ve C2, ona eşit olduğunu nereden biliyoruz belki? Bir tane eleman öyle olmaz mı?
Pardon. Bunu böyle tarif ediyoruz.
Yani W ona eşit olmayabilir. Böyle bir şey. Var mı öyle bir şey?
W böyle bir şey işte. W böyle değilse ne yapacağız biz? Öyle mi?
Olmayabilir.
Tabii ki. Okay, I understand. So you are asking this. What would be, for example, let's say W this, right? E2 wedge E3 minus E1 wedge E3, right? What is the dual of this? Okay. So dual of this will be just again I assume that I am in a vector space. Let's say, I don't know, if five-dimensional vector space, and this is my basis. E1, E5 is my basis, and this is my new basis. E1 star, E5 star, and I want to take the dual of this. So, according to my definition, I will have this. This is dual E2 star, H E3 star, but since I have only two terms, I will have 2 factorial, which is 2. And what about this one? E1 H E3.
Bunlar direkt böyle düşünmeyi yapıyoruz.
Efendim?
Bunlar direkt böyle düşünebiliyoruz.
Evet, evet.
Yani illa E1'den E'ye bütün hepsini belki olmak zorunda.
Evet, evet. Ama bir tane basis'i fix etmen lazım. Bu, this basis and this basis should be given. Otherwise, I mean, things get wrong. Peki. These are anti-symmetric tensor products, right? Anti-symmetric. You may ask, I mean, all right, there are anti-symmetric ones, but what about symmetric ones, right? Can't be think symmetric ones. Of course, you can, but it turns out that they are not. You don't come, you know. You don't see them much as you see anti-symmetric ones. But let me just define what symmetric tensor product.
Hocam, before the
Yeah.
Will we go through the basis for the range products? Or they are different?
Yeah, we will talk about that. For tensors, we know what's the weight, what is the dual, what is the basis, right? For tensors, okay, if you have, let's say, two vector spaces, if these are the basis elements and these are the basis elements, then we know that the I tensor Fj are the basis elements. So if you have n of them and m of them here, then you have n times n of them. For which it is similar, but this time we will be careful because if you have, for example, so in this case, this will have dimension n squared. But in weight product, you will have this, and if I and j are the same, it is 0. So they should be different. So you cannot just take n terms here and terms here. Instead, if you have n terms here, then you should have n minus terms here, right? And then E1 dash E2 is the same as E2 dash E1, right? Almost. There's only minus sign. So this element and this element are linearly dependent. Therefore, the dimension of this, the dimension of this will be what? N terms here, n minus 1 terms here. But then you can also switch them. So it will have dimension n times n minus 1 over 2. But we will come to that. Evet. Yani bir paralel kenarda iki kenar aynıysa alanı sıfır. Ona denk geliyor. Tamam mı? Wedge'leri her zaman alan hacim diye geliyor. Bu so you should always regard wedge product as a volume, sign volume or area. Okay. Now, what is symmetric tensor product? Symmetric tensor product is defined in a similar fashion. Namely, we define it this way: A symmetric product with B. Okay, this is defined to be, so this is definition. A minus B, instead of minus you have plus. Okay, but symmetric products, you don't see them much because they are not as useful as alternating or anti-symmetric products. Okay, this is how you define it. In anti-symmetric product, we have wedge sign here. Here you don't have a wedge sign, we just write like this. Yani bu yeterince kullanışlı olmadığı için bunun için özel bir notasyon üretmiyoruz. Hani üretmiyoruz. Tamam mı? Simetrik olanlar şeyler gibi değil. What about this one? A symmetric, B symmetric 2. What would be this? Well, we would have 6 terms, right? It will be symmetric. A cancel, B cancel, C plus B cancel, A cancel, C plus what? A cancel, C cancel, B plus C cancel, A cancel, B plus C cancel, B cancel, A. Bir tane daha almak lazım. Bir de B'yi var. B ve simetrikten kastettiğim şey şu. Bu ifadede herhangi ikisinin yerini değiştirirken bu değişiyor. Çünkü zaten bütün kombinasyonların toplamını aldınız. Symmetric means the following. In this expression, if I interchange two of them and write this thing, I get the same. So symmetric means this. A symmetric B is this. A symmetric B. This is the same as A symmetric B symmetric C. No. Zaten eşit mi? Yani şunu kastettim. Ya da ne bileyim C simetrik, A simetrik. Bunların hepsi eşit.
Ender simetriklerle bunları saklandıran noktalar oluyor mu? Yani diğeri daha kullanılabilir yapan şey.
Geometrik bir anlamı var. Uygulamasından ziyade hani yani bir şey geometrik bir anlamı varsa o genelde hani doğru şeydir, nesnedir. Geometrik şeyi pek yoksa o zaman hani sadece bazen tanımlanmışsın diye tanımlanmış gibi olabilir. Simetrik olanlar hani gereksizdir, lüzumsuzdur falan gibi bir şey demiyorum ama hani öbürleri kadar çok karşımıza çıkmıyorlar. Tamam mı? Karşımıza çok fazla çıkmadığı için de onlara özel bir isim vermiyoruz. Evet.
Yani şöyle bir şey yapıyorum. Biz şimdi base'de E2, E'ne kadar yani D entermişmiş. Ama şurada W alınca onda en kopya aldık. Yani dimension sayısı kadar kopya için olmak zorunda mı da? Yoksa?
Değil.
Yani farklı alalım.
Alabiliriz. Mesela integral alacaksan what you are integrating on R2, R3 or in general on a manifold is an anti-symmetric object. So it's not symmetric, it's anti-symmetric. Because when you are taking integral, you have areas and volumes and so on. Therefore, they naturally appear there.
Peki, herhangi bir özellik görecek miyiz? Bir onların planlarından böyle. Kanunları çok benzer.
Teşekkürler. İkisi yani acayip farklı şeyler. Yani birisi yani en tensör, simetrik tensör olursa bunlar zero var, bunlar zero. Okay. Okay, then this is the guys. Belki bu egzersizden önce bir tanım vereyim. Okay, definition. Okay, these are the space. Space. Any element, let's say V1, which we take in print extended power of V is called a phasor. Yani K vektör dediğimiz şey K tane vektörün vect product'ı. So a two vector is an element of the form A vector. Okay. Exercise 2. Şöyle aslında yani kütlelerin toplamları bu nedenle finite sums, but this exercise shows the following: any two vectors, okay, in let's say R3 is the form, A with G. So why this is important? Yani şunu söylüyoruz. A two vector has the following form. So two vector is an element in this, and it has the form something like this. I with I from 1 to whatever. Okay. I claim that this can be written as a single term. Yani mesela şöyle olabilir. Example. Mesela şunu düşünün. 3 tane E1 eksi E2 5 E1 artı E3 eksi E1 artı E2 5 4 E2 minus 5 E3. So what I claim is that this can be written as just A H B. Okay, just a single term. Now let's see why. How can we do this? Şöyle just. Okay, now wedge product is like cross product, right? And what we are claiming is that any vector actually in R3 can be written as the cross product of two vectors. If I give you a vector in R3, how can you find two vectors so that their cross product is this? Ne yaparsınız? Buna dik değil mi? İki tane vektör bulursunuz şöyle. Bu ikisinin cross product'ı genelde bu olur. Yani bir de boyunu ayarlamanız lazım. So the idea is similar. If you want to write a vector as the cross product of two vectors, then you need to look for vectors which are perpendicular to this one. And this is what we are going to do. So the idea is geometric. Okay, so what we do, okay, consider the basic. Aslında ben bunu yaptım. Şey, okay. For R3. Then this W, which is just AI which BI, it doesn't matter how many terms do you have, but each AI and each BI is a linear combination of the schedules. So you will have linear combinations of these things, wedge product. But how many different kinds of wedge products you may have? You may have E1 wedge E2, E1 wedge E3, E2 wedge E3, yeah, that's it, right? You have just three terms. So anything like this can be written like this guy. So alpha times E1 wedge E2 plus beta times E1 wedge E3 and gamma times E2 wedge E3, right? Because each AI and BI is a linear combination of E1, E2 and E2. Yani bu A'ları B'leri bunlar cinsinden yazıp çarptığınızda, değil mi? Sonuçta ya mesela A diyelim ki şu, işte 2 tane E1, 3 tane E2 artı E3 ve B de şu olsun bir tanesi. minus E1 plus E3. Bunu açtığımızda ne gelecek? E1 çarpı E1 o 0, E1 çarpı E3 değil mi? Başka bir şey yok. Bunlar şöyle olamaz mı? You may say that maybe I have E3, E1, but E3, E1 and E1, E3 are basically the same. You just pick up a minus sign, right? You can always break the gadget to this form. Tamam mı? Hı? Kaldırayım. Anlaştık mı? Her zaman o hale getirebiliriz. Eğer anlaşılmayan bir şey varsa söyleyin. Hani yok burası anlaşılmadı diye üstünden geçelim. Yani böyle sonuna kadar yazmıyorum çünkü çok zaman oluyor. Yani o benzer hesapları sürekli yaptığımız için. Peki şimdi ne oldu? So, I wrote this two vector average di one case is just something like this. A1, E2, E1, E3, and gamma into when E2. Okay. Sonra ne yapacağız? Ne dedik? Okay. So the geometric idea is this. Find two vectors which are perpendicular to this one. In other words, yeah, okay. So look for B in R3 so that WH B. İsterseniz şey yapayım, hani kolaylık olması için, for simplicity, let me just give some values to alpha, beta, gamma, okay? Because for V, I would use again some indeterminates and then things will get complicated. Suppose,
Can you hold that example also?
Yeah, but once I do that, you will see. Yapacağız zaten. Bunu nasıl yapacağımızı göstereceğim. Okay, so let's say this is just yani burada bunu açsaydık ne olacaktı? So this is equal var. Yazalım. Buradan ne çıkar? 3 tane E1, E3 eksi E1. Efendim? Bir de eksi E2, E3. Buradan ne gelecek? Eksi E1, E2, 4 tane E1, E2. Artı 5 tane E1, E3. 5 tane de E2, E3. Yani ne oldu bu? E1, E2 kaç tane var? Bu AT'ler eksi 3 tane E1, E2. E1, E3 kaç tane var? 3 tane burada. 5 tane burada. 8 tane. E1, E3. E2, E3. 4 tane de E2, E3. So alpha is -3, beta is 8, and gamma is 4. Okay, let's do that. So let me just say this is just 3 times E1 is 2 minus yok eksi 3 tane bu özür dilerim. Eksi 3 artı 8 53 artı 4 52 53. Hı. Ne yapacağım ben? I want to write this as a single wedge product. Here we have 3 wedge products. I want to write this as a single wedge product like this. Okay? And this is how we will do it. First, I will look for vectors so that when I do this, I get 0. So let's say V is this form: A times E1 plus B times E2 plus C times E3. So 0 equals WHB. Okay, so minus 3 E1 wedge E2 plus 8 E1 wedge E3 plus 4 E2 wedge E3 wedge product with 8 E1 E2 plus C E3. So when you open this up, you get what? Bu 0 verecek, bu da 0 verecek. Sadece bu geldi. Değil mi? Eksi 3 C minus 3 C E1, E2, E3. Right? E1 wedge, E2 wedge, E2. Because I have E1 wedge, E2 and I have E3. And then when you multiply with this one, it will give you 0 here, 0 here. Only this guy will give us something. 8 B, but you see, I have E1, then E3, then E2. If I want to write it in this form, then I have to switch this two, so I will have minus 8B. And what about this guy? Its product with this one 0, with this one 0, only this one will survive. I have 4A, E2, E3, E1, so this E1, so I have E2, E3, E1. I have to make 2 jumps, therefore sign on this still positive. So we have this. Now for this to be 0, E1, wedge, E2, wedge, E3. Now this is the 0 vector. This implies what? Minus 3, no, 4A minus 8B plus, no, minus 3C is equal to 0, right? Şunu daha güzelce yazayım. Four A minus 8B minus 3C should be 0. Okay. Now, can we find vectors that we yani, so whatever B is, so that this is 0, A, B, C should satisfy this identity. So what I can do, for example, I can choose A equals 2, B equals 1, and C equals 0. So one choice is there. B is what? Ne dedik? Yani 2 tane E1, bir tane E2, 0 tane şey. So this is one vector. Can I find another one? Artı olacak. Evet. So A is 2, B equals 1, C equals 0. another V, let's say this is one solution, another solution. Ne yapabilirim? A'ya 3 verelim. B'ye 0 verelim. C'ye 4 verelim. So 3E1 plus 4E3. Okay. Now let's look at the wedge product of these two. E1 wedge E2. You see this wedge product. If you take wedge product of this guy with V1, you get 0. If you take wedge product of this guy with V2, you get 0. Similar to W. That's why this guy should be basically W. Değil mi? W ne yapıyor? Bunlarla wedge product'ı 0. Bunun da 0. O yüzden bu W olmalı. Tamam mı? Well, it doesn't have to be W, but you will see that it is almost W. Let's see. So 2E1 plus E2, wedge 3E1 wedge plus 4E3. Let's see what we get. E1, E2 terimi nerede? E1, E2 sadece buradan var değil mi? Eksi 3 tane E1, E2. E1, E3 terimi nereden gelecek? Sadece buradan. Yani artı 8 tane E1, E3. E2, E3 buradan gelecek. 4 tane de E2, E3. Bu tam da bu çıktı galiba değil mi? I wasn't expecting this, okay? Suppose I make this 6 and this 8. So I will get minus 6, 16 and 8. Then I will just divide this by 2 and get this. So this is just coincidence, okay? But this is the idea.
Hocam, biz de tanesi sıfır yapmaya çalışıyoruz. Mesela yapmadığımız zamanlarda alabilir miyiz?
Yapmadığımız zamanlarda
Yani C eşittir 0, B eşittir 0 yaptık yani. Hiçbiri 0 olmaz.
o zaman olmaz. The idea is the following. The idea is the following. In R3, consider wedge, not wedge, but cross product of two vectors. If you have two vectors, cross product of two vectors, U and V, like what is the cross product? It's a third vector, which is perpendicular to both of them. So what I do, I want to write, given a vector here, I want to write it as a cross product of two vectors. What would you do? You would choose two vectors which is perpendicular to this one. Perpendicular means that product is 0, right? But here we don't have cross product and we don't have dot product. Instead we have wedge product. So, but the idea is the same. Instead of looking at these two equations, I will get this equation. This wedge, this is 0, and this wedge, this is 0. Okay, and I solve this. İki tane vektör arıyorum, çarpımı sıfırlıyoruz.
0 eşitlemek onun neyini?
Yani o zaman bu geometrik fikri kullanmıyoruz. Bütün şey bu zaten. Elindeki tek şey kullanmasın. Evet.
Can you say that the wedge product of V1 and V2 is always equal to multiple of each other?
Well, if W, so if, okay, if WV1 is 0 and WV2 is 0, then wedge product of these two is a scalar multiple of this gadget. But this is true in only R3. So in general, you may ask the same question I didn't write down the general question because, it makes understanding difficult because we have to deal with many indices. But the general fact is the following. Yani burada yaptığımız şeyin aynısı daha genelde doğru. And the proposition is this. So what we have done for R3 can be generalized, and the statement is this. Any n-1 vector in an n-dimensional vector space, n-dimensional space can be written as a single term exterior product or wedge product, exterior product of the form any n-1 vector W değil mi şuraya? Yani W şöyle yazılabilir. A bir bakayım nasıl yazmış? Evet. Böyle So what we put the same thing, but n equals 3 case. Any two vectors in a three-dimensional vector space can be written as a single exterior product V1 wedge V2, right? N equals 3 case. So we put this here just put this for n equals 3. Tamam mı? Efendim? Yazılabileceğini söylüyorum. Şey demiyorum. Her bu yani bilgileri nasıl seçeceğini söylemiyorum. Yazılabilir dedim. Burada yazdık ya. Burada yazdık. W'yu ben nerede yazdım? Ya bu W çıktı değil mi? So W is just V1 wedge V2. Bunun her zaman yazılabildiğini söylüyorum. Peki ispatı nasıl olacak? How would you prove this? You do the same, okay? What I have done over there. Work on this, and next time, if you cannot come up with the proof, I can do it on the board. But I will, let me say, so you will just repeat what I have done over here. Yeah. And you can do this because you will get a single equation like this one. There will be n terms, and you n minus 1 vectors. Yani birine 0 verip pardon. N-2 tanesine 0 verip diğerlerini bulacaksınız. Ya burada nasıl yaptık? How did I solve this?
Hocam bir tanesine 0 vermedik.
Birine 0 verdik. Diğerine 1 dedik, 2 dedik, diğerine bu şekilde yaptık. Burada vereceğim. 0 verimden 3 tane var. Yani o şey işte. N-1 bir tane vektör. Sorry. I think already Tuesday's lecture, but for today's lecture, I will Yani sonra böyle. Tamam. Bu halde
Belki 15 tane Hocam, ne olacak? Siz sorun.
Aslında çok basit bir şey. Şurada ağız oturayım. Sonra şuraya
bir şey eşit miyiz? Yani?
niye yaptın?
Biraz sıkmıştım ben yazacağım.
Yani notlarına bak, anlamadığım bir şey varsa söyle. Ya belki sadece hani örnek olsun diye öyle bir şey yazmışımdır. Böyle bir şey çıkacak falan diye.
Birazcık baktım.
Birazcık baktım pek yok ama bu süreye sileyim mi? Şey kapatayım. Seminere gideceğim.